All right, I'm going to knock out problem 12, and this is a pretty easy 5 mark question, in my opinion. It's just a straightforward use De Moivre's theorem to find the value of 1 plus I to the 10th. So all we do is take 1 plus I and write it in polar form. And so the R value is just the square root of 1 squared plus 1 squared. In other words, the R is the square root of 2. And the theta value is just the arc tan of 1 over 1, which is pi over 4, or 45 degrees if you're more degree minded. I didn't have to worry about adding pi to my inverse tangent because the complex number 1 plus I lies in the first quadrant. And remember, we discussed this recently, that the range of the inverse tangent is the right hand side of the unit circle. And so if your complex number lies in quadrant 1 or quadrant 4, you can just take the arctangent as is. You do not need to adjust it by adding pi. That's only for when it's in quadrants 2 or 3. So what I can do now is rewrite the problem. Instead of saying 1 plus I to the 10th, I just say square root of 2 times e to the I pi over 4. Or if you like to do the CIS, you can do CIS of pi over 4. And then I'm going to raise this to the 10th power. So if you raise the square root of 2 to the 10th power, every 2 of those will cancel out, leaving you with 5 copies of 2. So you have 2 to the 5th. And when you raise a power to a power, it's just multiplication. And so you have e to the I times 10 pi over 4, which you can reduce down to 5 pi over 2. 2 to the 5th is also a nice number, it just comes out to be 32. So you have 32 e to the I times 5 pi over 2. Now 5 pi over 2 is equivalent as an angle to just 1 pi over 2 because you can subtract a full circle from it. And so 1 pi over 2 points due north, and so we just have 32 times I. And I think that is it. Let's see, is that all check out? Sure. The original r is square root of 2. The original angle is pi over 4. Double that, and then go. Yep, that looks good to me. Okay, just want to double check. Sometimes they seem a little too easy, so 5 marks just for doing those couple of lines of work.